Hi, everyone. Thanks for joining me on today's podcast. Rejoining me today is Linda Lua as we continue our conversation on PCIe clocks and buffers. How are you doing today, Linda?
I'm doing fine. Thank you, Isaac. How are you doing?
I'm doing great. So, Linda, in our last podcast, we finished with you giving us an overview of our PCIe compatible clock parts, which includes our any frequency output clocks and our PCIe clock gens and our PCIe clock buffers. Would you mind giving us a quick review of that again?
Yeah, sure. Absolutely. So we have a very comprehensive timing portfolio, including clock generators and also clock buffers for PCIe applications. I think the first part that we discussed about in our last podcast is an any frequency, any output format clock generator, the 5332. So the 5332 supports PCIe up to Gen 4, and other than that, because it is an any output frequency up to 333 megahertz, it can also support providing reference clocks for FPGAs, gigabit switches, PHYs, memory. So you need to only use one device in your board if you have multiple different requirements. Other than that, we also have a family of PCI-specific clock generators. The first one that we talked about is the 52200 family, which supports PCIe Gen 1 to Gen 4, and the power supply is 1.5 and 1.8 volts. And if your customer is looking for a 2.5 and 3.3 PCI clock generator, we also have another family, which is the SI 5214X family. Other than that, to distribute the PCIe clocks, we have our fan-out buffers and also zero-delay buffers. To support Gen 1 to Gen 4, we have our new family of buffers, which is the SI 53200 family, 1.8 volts to 1.5 volts to 1.8 volts part. So if your customer is looking for a PCIe Gen 1 to 4 fan-out clock buffer, which is a 2.5 or 3.3 volt. We also have a family, which is the SI 5315X family. And we also have a zero delay buffer family, which is compliant to Intel white cover specs, the DB1200, the DB1500, and DB1900.
When is it appropriate to design in one over the other?
Yeah, so let's talk about the any frequency 5332. I will recommend that when you see designs with a diverse mix of different frequencies and different output formats, differential or single-ended, like when there is then FPGA on the board, the gigabit Ethernet switches, 5, memory, PCI links, 5332 would be a good choice. It can not only meet the stringent SerDes jitter requirements, at the same time it will meet the PCIe requirements. So you do not need multiple different clock generators or buffers to meet all these different requirements. You just need one device, which is the 5332, to provide all the reference clock on your board. And other than that, for the 52200 family, this is typically targeting for the 8 outputs and the 12 outputs. It is targeting more the data center, like servers, flash array storage, FPGA acceleration cards, and solid state drives, where the jitter performance is very, very critical, and they have to meet the Gen 4 specs with a lot of margin to ensure low bit error rate and to make sure that the communication between the endpoints does not break. And for the smaller clock generators, like the 4 outputs and the 2 outputs, those are mostly targeted in industrial or consumer applications like printers, femtocells, access points, test and measurement, where it also must meet the PCIe Gen 4 specs and also low power. So like consumer products like cameras, docking stations, personal storage, hard drives or solid state drives, the low power consumption will extend the battery life and meets the energy requirements. And other than that, the zero delay buffers, this is really easy because whenever you see any Intel Xeon x86 platforms like Romley, Grantley, Pearly, you just need to ask your customers, how many outputs they need, and we definitely have a solution for that because we do have reference designs with Intel on their white cover specs, like I mentioned before, the DB1200, the DB1500, and the DB1900.
I see. So with all these offerings, what exactly are Silicon Labs' most differentiated features for their PCIe clocks?
So our PCIe clocks, especially for our new generation, and we have the highest jitter performance. The industry standard limit for PCIe Gen 4 is 0.5 picoseconds, and in our data sheet now for our devices for our clock generators will meet a max RMS phase jitter of 0.4. So this ensures enough design margin to meet Gen 4 comfortably. So with the max of the 0.4 RMS phase jitter, we provide around 60% jitter margin for PCI Gen 3 designs. So if you have a Gen 3 design and you're not moving to Gen 4 right now, you can still use our 52200 family. So this will pave a way for you to migrate to Gen 4 easily in the future. Another benefit that we have is the lowest power consumption. We are the industry's lower power consumption. 1.5 to 1.8 volt core design minimizes the power consumption while maximizing battery lives. So for example, for the 2 output, which is 52202, we offer the lowest power consumption in the industry at about 41 milliwatts, which is 10% lower than one of our competitor in PCI family. And also the 5202 part supports individual output enabled control pins, so you can turn each of the outputs off to further reduce the power consumption. Other than that, other than the highest performance, lowest power consumption, we also provide the highest level of integration. All our clock generators and buffers that supports PCIe supports a push-pull output driver that integrates all external resistors. We support either 85 ohm trace lanes or the 100 ohm trace impedance. We also have internal power filtering that reduces external component count and also prevents power supply noise from affecting the jitter performance. The push-pull output buffers do not require any external termination resistors, so this will save you about 50% of board space compared to competing solutions. So by giving the highest level of integration, we provide very, very simple configuration. So we reduce the complexity in your design, we reduce your BOM, and we also have other features in the device like spread spectrum, output enable, and frequency select capabilities either via hardware pin or I2C.
With all of these differentiated features and offerings, how can we ensure customers will meet their PCIe requirements?
As we discussed earlier, because we have the highest performance in jitter, all our PCI compliant clocks provide a wide margin to the spec limit. So this allows for different design configurations like cascading buffers, long traces, system noise, and others. So to confirm meeting the PCI specs, be it Gen 1, 2, 3, or 4, customers can use our free downloadable PCIe clock jitter tool. This tool measures the jitter of the reference clock. So you can select to measure jitter for Gen 1, 2, 3, so there is a radio button for you to turn on and off for each of the generation. The tool will give you a comprehensive report of the jitter measurement as well as a very simple summary table to show if the reference clock passes or fails the specific PCIe specs. This tool does not only need to be used with Silicon Labs devices. In fact, we know that many of our competitors in the same space uses our tool to measure their parts compliance. We're proud to say that this tool is endorsed by some of the biggest developers of PCIe specs. So Silicon Labs PCIe clock jitter tool has become the industry standard tool for PCI compliance. Go ahead and Google PCIe Learning Center and you can download the tool from there. Again, it's a free tool for everyone to use.
Great. Thank you for taking the time to give us such a thorough description of our PCIe offerings at Silicon Labs. Thank you for taking the time today. I hope you have a good one, Linda.
Thank you. Thanks for having me, Isaac.